Okay, chapter number 7 is we have a couple of topics that we're going to discuss in this chapter. The first one is Linux boot process. What happens when we power on or reset our virtual machines from that time to the time when we see the login prompt on the system. So that's our first topic, and then the next one is kernel management. We're in today's class we're going to download a kernel a, an updated kernel from a website to our systems, and then we're going to install it on our machines. And then I'll show you the difference between the new kernel and the old kernel and how to switch between them. And there is one other topic which is on syslog. So what happens when different alerts are generated on the system? Where do they go? Do they where are they recorded, and so on. So Linux boot process, various phases, and then the grub is an interface between grub is the interface that allows us to interface or modify pre-boot configuration of the system on the system. So for example, if we forget the root user password or we don't know what the root user password is, there is a method, there is a step-by-step procedure that we have to follow in order to reset the root user password. So we interact with this pre-boot interface called grub. So I'll show you we'll talk about it, and I'll show you how to modify or how to reset the root user password. Managing the kernel, introduction, check and understand kernel version and the directories where kernel information is stored, and then we're going to download the difference between install and upgrading a kernel, and we're going to download a kernel from a website and we're going to install it on our system. And then introduction to systemd, which is a new concept in version 7, in enterprise Linux version 7. So what systemd is, what the units are, targets are, and so on, and how to manage them. System logging is the last topic. Introduction, configuration file, and how to use it. This video here, how to add a boot time kernel parameter to the Linux kernel. This is basically this is also important from the R8CSA. So there are a number of topics that are very important from the R8CSA and R8CE exams perspective. The first one is in this video, how to reset an unknown root user password. So you'll be given a virtual machine on your exam station and you won't know what the root password is. So this video helps on how to do it. How to install a new kernel version is also discussed in this chapter. So 2, and then this video, add a boot time kernel parameter. 3, and how to use the systemctl command to control the systemd services and units. So there are 4 important topics from the exam perspective discussed in this chapter. So what happens when we power on Enterprise Linux, Red Hat Enterprise Linux, CentOS, Oracle, Scientific Linux? When we power on our virtual machine or a physical box, until the time we see a login prompt on the machine, there are 4 major phases that the Linux system goes through. The first one is referred to as the firmware phase or the BIOS phase. On any computer, the BIOS is the first software code that is executed on the system, which performs a power on self-test on system hardware components. It initializes them and makes sure that there are no hardware issues there. If there are any hardware issues, major hardware issues, it won't boot up. If there are minor hardware issues, it shows us a warning on the screen, but then it just continues with the boot process. The 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 other thing that the BIOS does is to search for a boot device which contains a bootloader program. So for Linux, the bootloader program we use is called grub, GRUB. It stands for Grand Unified Bootloader Program. And this program is loaded into memory. So once the grub program is loaded into memory, it calls a kernel. It tries to locate the kernel of the operating system, which is by default, which is located under the /boot file system. So kernel configuration files, the actual kernel file, and memory and image of the kernel, everything that is related to booting the system is stored under the /boot file system. So what in the grub phase, it finds the default kernel from the /boot file system, it loads it into memory, and then it initializes it for use for to continue with the boot process. As part of it, it also loads some modules, some kernel modules that are required to support the boot process. For example, the module for the keyboard, modules for virtual hard disk or physical hard disk that are required at the very early stage of the boot process. The next phase, the third phase, is called the kernel phase. In the kernel phase, the kernel loads a read-only image of the root file system into memory, which is called initial RAM disk. This read-only image is mounted on the system, and then it uses this read-only copy of the root file system to load additional modules that are basically stored in that file system. So it loads those modules to support the boot process. And then the final stage, which is final phase, which is called the initialization phase. This is something new in version 7. So what happens at this stage is that the kernel transfers the control over to this new initialization scheme, which is referred to as systemd. Systemd is used for system initialization and system and service management in Red Hat Enterprise Linux version 7 and all its clones. And all the services that are enabled for auto start at the boot time, they are started. Any file system that are marked in the fstab file for auto mounting at system startup, they are mounted. And any other configuration that is enabled for to activate at the system initialization or system boot time are also activated. And the default boot target, which is on our system, is called graphical, which means all networking services are started, all other services that are marked for startup in multi-user mode and in graphical mode, they are started, plus the desktop environment, plus the graphical desktop environment is also started. So, and then it presents the display manager, which we see on our console, where we log in. We enter our username and we enter our password, and then we get in. By this time, your networking is also initialized, and the network interface adapters are configured. The connections are activated, and we're able to use the PuTTY software or any other SSH client software to connect to our Linux system. And then at this time, you can start your applications. You log in and you can run your commands and programs or anything that you want to do. So basically the system is up and running and it is ready to be used. So basically 4 phases: the firmware phase, which is the BIOS phase, the grub phase, which is a pre-boot phase, and the kernel phase where the kernel initialization takes place, and the initialization phase which starts all the services that are configured to start at boot time on the system. Now, how do we manage grub? How do we interact with grub? Now, for example, you have multiple kernels installed on your system. You uh, at the first installation of Linux, we have one kernel installed, and which is also referred to as the default kernel. So whenever you reboot your system, that kernel is loaded into memory. But what if you have multiple kernels? Um, you have multiple kernels installed because you needed them over the period of time because of a new application that you want to run on the system, and that application requires a higher version of the kernel, or there was some bug in the previous kernel and you had to upgrade to a new kernel to avoid those bugs on the system. So in such situations you can move from one kernel to another at the time of system boot up when you see the grub interface on the screen. So you can boot with a non-default target, or you can boot to a non-default target. For example, graphical is the default target. So when you boot your machine, by default, it starts the desktop at the very end, and then it displays the display manager or login manager screen. We can disable that. We can boot our system into multi-user mode, but with graphical capabilities disabled. So there are multiple um, operations that we can perform by interacting the grub menu. Then there is this configuration file, which is anything that is related to the kernel is stored under the boot file system. There is a subfolder called grub2. There is a subfolder called grub2 under the boot file system, and this file here, grub.cfg, is the primary configuration file for the grub, and it is located right here, grub.cfg. It is stored right here, but we can, at the pre-boot level, at the grub interface level, we can call it. We can load the contents of this file into memory, and we can modify them if we need to. But any modification that we do here at this interface will not survive at the next reboot. They are not permanent. They are affected only for this one particular boot. The next time you reboot your system, those changes will be gone. There is a different procedure to make those changes permanent. So we interact with grub when we have a situation like we forget the root user password. Our system is unbootable for XYZ reason. There is a problem with the fstab file, for example. We define an entry for a file system that does not exist on the system, or it does exist, but there are issues with the definition. So that's why in the previous class I stressed on the need to ensure that there are no typos and there are no issues in your fstab file. So in situations like that, we will need to interact with grub in order to fix those issues and then make our system bootable again. This exercise here, 7-1, is basically what is in this YouTube video as well. So now, do you guys want me to actually show you how to reset the root user password here on my console, or you want to take some time off, maybe 10 minutes, and watch this video? We can do we can do either or. Okay, so I'll do this exercise here, exercise 7.1. So in order to do that, I will, where's my, this is my console, right? So in order to do that, I need to shut down the system, or I need to reboot the machine. Let me reboot it right now. Let's say we forget the root user password, or we don't know what the root user password is, and we are unable to perform any root privileged operations on the system. Okay, at this point here, it shows that there are two kernels currently available on the system. The first one is the default kernel, is the default boot kernel, which is CentOS Linux version 3.10.0, 5.14, Enterprise Linux 7, x86-64, and this is the main kernel. The other kernel is only used in some very specific situations when your system is unbootable. So it's basically a kind of a, save mode boot in Microsoft Windows. So this is our primary kernel, and as you can see at the bottom of the console screen, it says use the up and down arrow keys to change the selection, which we have done already. Press E to edit the selected item, or C for a command prompt. Now we don't need to go to the grub command prompt. There are hundreds of commands available there that can be used for a number of different operations, but we don't want to do any of those. We want to load the grub.cfg file content here. So we need to press the letter E to edit the selected item. So press E at this point, and this is the grub.cfg file. So what we need to do is to go to this line, Linux 16. Are you guys with me? Go to this line, Linux 16. This is the name of the kernel, VM Linux 3.10.0, 5.14, etc. The location of the root file system, and it is mounted in read-only mode. And then there is a crash kernel, etc., etc. So go to the end of this line. Go to the end of the line that begins with Linux 16. And over here, space, init means initialize, and use sysroot /bin/sh. What happens is that the root file system, which is mounted in read-only mode, is mounted on /sysroot directory. And then in that directory, there is a subdirectory called bin. And in the bin directory, there is a shell file called sh, Bourne shell file. We're not using the bash shell. Bash shell is located, basically /bin/sh points to the bash shell. So we enter this string at the end of the Linux 16 line, and then we press Control X. As you can see on the screen, on this screen here, it says press Control X to start, Control C for a command prompt, or escape to discard edits, but we want to continue with the boot. So press Control X here, and then now the system is booting up. The system has booted up in emergency mode. As you can see on the screen here, it says entering emergency mode, exit the shell to continue, and so on. So this is the command prompt. At this command prompt, we run this command called root, change root. make the root file system, make the read-only root file system to appear as if it is mounted on the / directory. Otherwise, for every command, we will have to run / sysroot / bin and then the command name. And even then we would have problems because the entire absolute path would have changed. So this is the first command. So we run this command in order to make the read-only root file system appear as if it is mounted on the / root directory. So change root / sysroot. The next command that we need to run is to remount the root file system in read-write mode, because when the kernel is initialized, it mounts the image of the root file system in read-only mode. So we need to remount the root file system in read-write mode. This is the command, the mount command, -o, any options, remount, rw. So remount the root file system in read-write mode. Now the root file system has been mounted in the read-write mode, and now we can use the passwd command to modify the root user password. Now when we run the password command as the root user, we don't need to specify the name of the root user account to modify their password. We simply, just 1 minute. Now change the root user password. Run this command, change the password. I'm not changing my password, I'm just keeping it to the same. So root 123 and then root 123. Now if you just press the enter key here, then there will be no root user password. So make sure you enter something. Now it says all authentication tokens updated successfully. The password has been modified. The next step is to use this command called touch, and in the /, which is the root file system, the top level root file system location, create this file called auto relabel. We run this touch command to create a hidden file directly at the top of the root file system called auto relabel, which means that when the system reboots, apply SE Linux labeling on all the files in the system, and in particular the files that we have just modified. So which file is modified when we run the password command? It's the shadow file. We'll talk about the shadow file in user and group chapter. So that is also done. Now we need to exit out of the chroot, the chroot command that we executed. Basically, chroot command creates a jail in which we perform all these activities. Now we want to get out of that jail by running the exit command, and then we're going to run the exit command once again to reboot the system. There you go. Oops. Generating something. Let's reboot it and see. and the now it's going to, as you can see on the screen, it says towards the bottom, SE Linux targeted policy relabel is acquired. Relabeling could take a very long time and so on. Warning is skipping the read-only file system. So right at the moment, it's applying the SE Linux, labeling, or it is relabeling the files. As soon as it is done, the system will be automatically rebooted. Okay, so my system has been booted up. It's running. Let me restart this PuTTY session here, and I should be able to see this login prompt, and I am able to log on to my system. So I'm back here. Uptime 8:53. Okay, so the next topic is to manage the kernel, and so basically the Linux kernel is a set of modules. Modules are device drivers, software components that are called modules, and they work together as a single unit, and they basically allow programs and applications, services, and us, the users, to use the system smoothly and efficiently. So anything that all the hardware that the Linux system sees is managed by your kernel, and there are modules for every hardware component that are integrated into the kernel, and the kernel uses those modules to communicate with hardware devices, to communicate with software devices, and to talk to us, the users, talk to the kernel, applications, programs, and processes, etc., etc. So basically, the kernel is the core of the operating system. Everything circles around it. Everything is controlled by the kernel. And so the kernel, there are some components, there are some modules that are static to the kernel, and then there are some modules that are dynamic or dynamically loaded. Static modules are those modules that must be available in order for the system to work at a minimal level. So for example, when you boot your system, one of the primary modules that the kernel requires is a keyboard module and your monitor or VGA module, basic video modules, and so on. And dynamically loaded kernel modules for services that are, sometimes you use them, sometimes you don't. So these modules are loaded when you activate that service, and they are dynamically unloaded when you don't use them. For example, Bluetooth devices. At the time of system installation, the installation program selects all the modules that are required based on the type of virtualization you're going to use on your system, based on the type of hardware available on the system, and so on, and the processor architecture, and so on. Now, in most cases, the default kernel that we install on the system is sufficient for our use, but sometimes applications such as SAP or Oracle database, or some security software products, or some other application, they require a minimum level of kernel version to be available before they can be installed or used on the system. For example, on our system here right now, if I run this command uname -r, it shows us that the current kernel version running on this system is 3.10.0, and this is the 514th revision from Red Hat, and this is designed for Enterprise Linux version 7, and this is 64-bit. So this is the kernel version that is currently running on the system. Now, if you want to install an application on this system, for example, SAP, and it requires kernel version 3. 15.25, then you need to ensure that you download that kernel or the higher version of that kernel and install it on the system. And also a higher or a newer kernel version brings new functionality and bug fixes and any enhancements, etc., to the system. So we run this command uname with the minus lowercase r option to display the release and version information of the kernel. We can also use the rpm command. The rpm command will tell us the name of the rpm package kernel, the name of the rpm package associated with this kernel, and this is the breakdown of the version information. So 3 right here, it means that the third major version of the Linux kernel. The current major version is 4. 3 is the previous major version, but it is very stable, and Enterprise Linux, this is version 7.3. It uses 3.10. 7.4 is also out, which also uses 3. I think 3.11 or something. But no Red Hat Linux version is available on 4.x kernel at the time. And then this 10 indicates the 10th major revision of the third major version. 0 indicates the 0th patch version of this kernel, and this 514 here is the Red Hat customized kernel version, Enterprise Linux version 7, and this is for the 64-bit architecture computers. There are a couple of directories on the system that the kernel uses to maintain files. One is the /boot file system, which is where all the files, the kernel files, the configuration files for the kernel, the grub configuration information, the actual kernel file, the root, the read-only root image, etc., are located. So cd into the boot file system and run this command ll here. And as you can see, this is the current kernel, right? The name of the kernel is VM Linux, and then the version of the kernel. Associated with this kernel is this configuration file, which goes with this kernel. So config dash and then the exact same kernel version number. And this init RAM image, which is loaded by the kernel in read-only mode, or when we boot the system in emergency mode, this is the init RAM file system, or this is the root file system image that is loaded on the system. So the kernel version associated with these files identify them, which kernel they belong to. So this file belongs to this kernel, this configuration file belongs to this kernel, and so on. And then the other file system that is of interest and used by the kernel and maintained by the kernel is the /proc file system. The /proc file system is a memory-based file system. Information is stored in this file system is lost when we shut down the system, and information in this file system is recreated when the system is boot up. And throughout the operation of the Linux system, this file system keeps track of any changes that are made on the system, any runtime changes. For example, if I make any changes to the network interface configuration, the information is recorded in this under /proc in some directory structure. A new file system, a new process is started, a new command application is started. Direct subdirectories or subfolders are created for each process that is running on the system. And then the kernel maintains the information related to that specific process and all that information is stored here. And as you can see, for process number 388, which we can identify with the ps command, pipe grep 388, this is the process number 388. It's one process, single process associated with the XFS file system that whose support is available on the system. There are so many different files where information for this one particular process is stored, right? And these are all zero length file. All these files are zero length. Why? Because they are stored in memory. They are memory based files. They are somewhere located in the physical memory of the system, but they're not taking up any space on the disk. So /boot and /proc. And an example is also provided here for the cat /proc/meminfo. This file stores information about the current memory information on the system. So total memory on this system, free memory on the system, available memory on the system, amount of memory space taken by the buffers, cached memory, swap cached, active, inactive, etc., etc. And then swap information here as well. Total amount of swap space, how much is free, and other details. So all this information is specific to the memory that is on the system. And then this file here, proc CPU info. This file stores information about the processor that this system sees. Processor number 0, identifier is this, CPU family is this, CPU model is this. Model name of this CPU is Intel Core i7-3610QM CPU, and it is running at 2.3 gigahertz speed. Stepping by other details, cache size in the processor, and so on. So all the details that is specific to the processor which your Linux system sees is recorded in this file. And if we allocate another virtual CPU to the system, that information will be reflected in the same file after we reboot the system. Now to the question, is it good practice to have a latest kernel always? No, it's not a good practice because the latest kernel does not include everything that you might need on your system. So the best practice is to have the kernel on the system that is recommended by the application vendor that you are going to run on that Linux system. Because if you're running at the latest version and that application requirement is to run a kernel that is 100 versions behind, then and there is any problem with your application, you might end up with issues with your application support organization. So unlike in Windows where we run the latest and greatest patches and everything, we don't run the latest kernel version on our production servers. I'm talking specifically from the production environment. In your lab environment, in your test environment, yes, you can use them. But in production environment, I haven't seen any system in any IT organization where I've worked where they're running the latest kernel version. Now, we can install a kernel while the existing kernel configuration remains intact. We can upgrade the existing kernel to a level that is desired or which is required. So there is a difference between installing and upgrading in Linux. Installing means that you are not, now this is just for the kernel. You're installing a kernel without making any changes to the existing kernel or its configuration. Upgrading means that you do not want the existing kernel to be available on your system. So you upgrade it. So you remove the existing kernel and you install the new kernel. While installing is to install a new kernel without affecting the existing kernel, and that is the recommended practice in production environment. So we always upgrade the Linux kernel. The benefit is that if there's any problem with the new kernel, we can always boot our machine with the older kernel. So always install the kernel. If you're using the RPM command, the option is the minus lowercase I option to install it. And if you're using the yum command, use the install subcommand. So yum install and the name of the kernel file. Now this location on this website, the rpmfind.net, is a website where we can download a higher version of the Linux kernel for free. So let me share my rpmfind.net. This is the website. You can also browse it on your systems. And RPM Find Mirror located at, somewhere in France. Go directly to the RPM database. Yes, we can go, or we can perform a search, the kernel packages. So type kernel and then -3 maybe, and see what happens. It brought nothing. Architecture x86_64, system CentOS, and just search for kernel. Let's see what it comes back up with. Two sites kernel 3.10.0693, which is a later kernel, which is the default kernel used in 7.4. Right now on our systems, it is uname -r, which is 3.10.0.5.14. So let's download it directly to our Linux system. Now I think if you go to the console, you should be able to, I'm going to log in as the root user on my desktop computer. Root, and then root123 is my password. I think I do have access to the internet directly from my Linux system. Open terminal, and Firefox should be there, so let's run Firefox directly here. Yeah, I do have access. So CentOS.org. I think the kernel, we can download the kernel from CentOS.org as well by rpmfind.net. Let's go there. And then go to the RPM database for the kernel. So kernel, and then system is CentOS, and architecture is x86_64. Hit the enter key, and this is the kernel that we are interested in. This one here, 3.10.0.693. And I want to save the file, and I want to save, it's saving the file since I'm running this command as the root user, so this file is once the download is complete, we should be able to see this file under /root/downloads. So this is my system, my home directory, and there is a subdirectory here called downloads. CD into that directory and the kernel is there. At the moment, if I run this command uname -r, it shows that the kernel is 3.10.0.514. The new kernel is 3.10.0.693. So let's install it. We can use the yum command, right? And then install, and then this file name. I've used / to reference the current directory. So I'm using this path to the kernel file as a relative path. So yum install /kernel. I could also use yum install /root /downloads /kernel file name. Let's see what happens. Now, as you can see in the output, as part of the installation of this new kernel, it will also update an existing kernel package which is called kexec-tools. It is also going to download and install Dracut config rescue Linux firmware in order to support this higher kernel version on the system. So the dependency check was performed by the yum command, and it found all the dependent packages and it selected them for inclusion in the installation process. Now let me just press no here. We don't want to proceed with the installation. I want to show you something. What if we want to use the RPM command with -ia option, V for verbosity, H for hash sign, as we discussed in the previous chapter, and then specify this kernel file name and see what this command reports. It reports that there are dependency issues with the those of you who wanted to use the RPM command. This is not going to be an easy task because this higher kernel version requires additional packages to be updated. So the yum command would be your best bet to install a software on the system, which means that it will take care of the dependencies automatically. So let's use the yum install command, the yum command with the install. So all dependencies are selected, and let's select Y. Now since this system has access to the internet, and we have set up access to the CentOS repositories that are available on the internet. So what the yum command is doing at the moment, it is using this local file, the kernel file, to update the kernel, and as part of the kernel install process, it is downloading and getting the dependent packages from the repositories. Verifying, and in the output shows that the verification is complete. The kernel package 3.10.0.693 has been installed, and this package was updated. These are the dependent updates, dependent packages that were updated, and it's complete. We run the uname command with -r, and we still see the old kernel version. Now in order to use the new kernel version, we have to reboot the system. And any new kernel that you install on the system automatically becomes the default boot kernel. So now if I reboot my system, it will boot up with the new kernel. So I just executed this command, and here's my console, and you'll see more than one kernel here. So this becomes the latest kernel. This becomes the default kernel, which is the one that we just installed, 3.10.0.693. And it will automatically boot if I don't interact with the grub auto boot process. This is the old kernel is still there, and we can select it to boot, but this is the default. So let's boot it up. So a number of services have been started, and the display manager is going to appear next. And we can try here, restart session, and there you go. Root 1, 2, 3. And we're in. We can use the uname -r again, and the command reflects the new kernel version. So this is the new kernel that is now active on the system. The next topic is about systemd, which is the new system management service and system management scheme introduced in version 7 of the Enterprise Linux. What systemd is, basically systemd stands for system daemon, which means a daemon is any process that runs in the background on a Linux system. So system is the process name. System is the process name, and systemd is the systemd is the process name. So it stands for systemd, and it runs on the system, and it has brought more capabilities. It has brought advanced system and service management capabilities with it as compared to the older system initialization scheme, which was called sys5 and system 5 initialization. Which was called system 5 initialization. Now on my Linux system, if I run this command ps -eaf and pipe grep to systemd, let's see what it shows on the screen. It shows that there is a process called systemd, which is located in the /u. The associated file is located under the /usr/lib/systemd directory, and the name of this file or process is called systemd. This process is running, and the process identifier for this process is 1, and it was started by process number 0, which is swapper process that is created by the kernel during its initialization. So systemd is the first process that is started when the system enters the system initialization phase, and it is right there. So this process is running, and in the newest version of Linux, it has brought a number of capabilities to the system. Yeah, that's right. It is similar to System32 in Windows. So some of the major advantages that systemd has brought to the Linux system is, number one, parallel processing of startup scripts. Now there are a number of services that are defined on the system. These services are is started up when the system boots up. These services are shut down when the system goes down. So what happens in the older version, what happened when the Linux system was booted up, it started, it tried to start one service. And if that service required the activation of some other service, then it would wait before that the dependent service was brought up. In system D, that doesn't happen. So multiple services start up at the same time. Multiple services start up at the same time, and if they really need the presence of or the completion of some other service, they create something called socket. For I'm talking about the networking services in particular. They create a socket and then they go ahead and start the remaining portion of the service. And as soon as the other service is up, the socket makes a connection of with the service and it properly starts up. So with parallel processing of startup scripts, the Linux system startup time has reduced considerably. Automatic handling of service dependencies. If one service depends on another service, then it takes care of the dependent service automatically. It starts it up um, by itself, and then as soon as that dependent service is up, it the the given service start itself up as well. So just like in with the yum command that takes care of the dependent finding, installing dependent packages, in systemd the services are automatically started up as long as they are marked for startup when the system is rebooted. So it handles that dependency on its own. And then on-demand activation of services. Now, not all the services are needed all the time on the system. For example, Bluetooth. If you're not using Bluetooth, this service is stopped. It deactivates. But as soon as you start using that service, as soon as you want to use that service, it becomes the system automatically activates it. So these are three major benefits of the systemd initialization scheme: parallel processing of startup scripts, automatic handling of service dependencies, and both of these have increased the have reduced the boot time of a Linux system. Now, if you really want to experiment that, then download a copy of CentOS 5.11 version, for example, and install it in a different virtual machine. And then have your this 7.3 virtual machine there, power both of them off, and then start up both machines at the same time. And then you can, just compare it for yourself, the difference in time that it takes for these machines to come up. There is the fundamental unit of fundamental part or the object that is used to control systemd objects, and it is called unit. A unit is basically a configuration file that stores required information in it and that unit is associated with a service or some hardware initialization or some application. Now, for example, if I run this command called systemctl, this is the primary command that is used to control the systemd objects, units, and we're also going to talk about target and so on. And pipe it to more, systemctl, pipe it to more, and as you can see, the heading up there, the unit. So this is a unit, name of a unit. This is another unit, and then There are so many different units running on the system, and each individual unit is associated with something. So this means here that there is a process file system which is /proc. It will be auto mounted. So there is a file system which is, there is a memory based file system which is, it stores runtime information of the system. It will be automatically mounted. So this is a unit configuration file. It is a unit that is automatically started up when the system comes up, when the system is booted up. Similarly, this boot.mount, this means that load all active file systems that are defined in the etc fstab file. Then if you go further down, maybe to the end, timers is another unit file, system initialization is another unit file. The swap space that is created, a virtual file that complements the system memory. Sound, sockets, slices, remote file systems, um, the networking, multi-user, etc., etc. So for every service, there is an associated unit file, and the unit file stores configuration information. Now let's take a look at one of the configuration files. There are two directory locations on the Linux system where the unit files are stored. One is the /usr/lib/systemd directory, where all /system. This is the directory location where all the default systemd unit files are stored. And then there is another directory location which is in the /etc/systemd/user directory, which is by default, which is empty. If you modify any of the existing service unit, any unit configuration file, a copy of that file will be made in the etc systemd user directory, which means that the custom unit configuration files are stored under the etc systemd user directory, while this directory here, user lib systemd system, stores the default unit configuration files that are shipped with the operating system. Now there are a number of files here. Basically there are 12 different type of unit configuration files. There are files that with extension .service. There are several of them. These unit configuration files are related to services. The file system mount service, the update service, the reboot service, the login service, the system halt service, the system shutdown service, the NFS service, and so on. So most of these files, if I pipe the output to the NL command, it will show how many service unit configuration files are there. There are 257. Then there are certain unit configuration files with extension .target. These files, there are 60 of those. These files are these unit files are there to achieve a certain level. For example, if you want to mount all the file systems that are currently mounted on the system, there is a target unit file, which is umount, and then there is an extension with it. And then swap has its own target file, and system shutdown, different run levels on the system, power off, printer, reboot, and so on. So when you run the reboot target, for example, it means that execute all the unit configuration files that are required in order to successfully reboot the system. If I say that I want to change my target into I want to achieve this U-mount target. This means that execute all the services on the system that are required to unmount all the file systems on the machine. And then there are some unit configuration files with dot slice. Oh. Okay, let's pipe the output and exclude the target and exclude the service files. Do you know what this command will do when I run it? The ll command grab with the -v option. -v means do not show any lines with containing the this pattern target. And then another grab command -v means do not show any lines that contain this string service in the output. And then show everything else. So there are some unit configuration files with .socket extension, with .path extension, with .timer extension, and so on. So there are a total of 12 unit configuration file types. However, we deal with the service configuration files in most cases, the service unit configuration files. Now let's take a look at one of these files. Maybe the cron-d service that we used in one of the previous classes. Let's see what it contains. If I run the cat command on cron-d.service file, this is what it contains. So at the beginning of the file, it shows a description that this unit file is for the command scheduler. The service that this unit file provides is a command scheduler. And then what should happen after this service has been started up successfully? It should run the audit service. It should run the system user sessions service and also run the time synchronization service. So cron-d service requires that these three services are started up after its own startup. Environment file, the configuration file for this for cron-d.service configuration is located in the etc sysconfig directory, and it is called cron-d. You can run the etc the sys ll command and you can see the file there. It's a very short file, 110 bytes in it, and this contains the configuration data for this service. And then it says then that start this service by executing this command and stop this service by executing this command. Well, if this service dies down for any reasons unexpectedly, then restart it by running this command. And it also shows under here that multi-user operating mode, multi-user system operating mode requires it, wanted by, which means that in order to get to the multi-user system boot level, you need to have cron-d running. And let's take a look at some other, maybe TMP mount this file. Now this unit configuration file is not a service configuration file. However, service unit configuration service units will reference this file. So what it says here, this is a short description that this refers to temporary directories. Temporary directories is the /tmp directory, and then the location of its manual pages, the documentation location, and some other conflicts means that if the U-mount target is running, which means to unmount all the file systems, you cannot mount this file system. There is a conflict between starting up or mounting a file system and unmounting a file system. So when the unmount is taking place, you cannot mount a file system. And this file system should be mounted before all local file systems are mounted. This is the name of the file system, and it mounts with /tmp, and it should have a sticky bit enabled on it, which is identified with the first digit, with this digit 1. 777 means 777 permissions, and local file system, yeah, it is mounted as part of the local file system. Now if we look at the TMP file system here, you can see that it has a sticky bit on it, which is identified with the lowercase t here, and it has read, write, execute, and read, write, execute permissions on it, right? And if you run the df command with the -h option, you will see /tmp. You'll see the temporary file systems here. These 3 and these 2 additional file systems. These are all temporary file systems, and they are there. Okay. Now a service can be, a systemd service can be activated or deactivated. Activated means the service is running, and deactivated means the service is not running. And or it can be in the process of being activated or deactivated. So in other words, it is the service is transitioning from its running state to shutdown state, or from shutdown state to running state, or the service can maybe in a failed state. A service can be enabled or disabled. Now there's a difference between enabling a service and activating a service. Enabling means that upon next reboot, this service will be started automatically. Disable means the service will not start automatically at the next system reboot. Activated means the service is running. Inactivated means the service is not running. Now we use this command called systemctl for most, if not all, systemd operations. So without any options and arguments, when you run this command, it shows the status of all the units that are currently loaded on the system, loaded and active, subcategory and description. So for example, in the second column, in the first column, we see the unit configuration file name with an extension, whichever extension is applicable. And then in the second column, it shows whether the service is loaded or not. And in the third column, it shows whether the service is active. Active means the service is running. And then there is a subcategory which provides a very short description of what that service is. So waiting means that this service is waiting for something in the background. Plug means that the whatever this unit file is associated with a device device file, it is plugged in. So it's a CD-ROM, VirtualBox CD-ROM on CentOS, right? It's plugged in. This is also plugged in. Gigabit Ethernet card, your AC97 audio control plugged in, VirtualBox hard disk, which I'm using with this virtual machine, is plugged in. LVM, logical volume management, physical volume, is plugged in. This file system is mounted, active and mounted. NFS is configuration is mounted. Then there are some virtual file systems that are currently mounted. And then if you go further down, the swap service is active and running. Sound card is active and running. Sockets, remote file system. So all these services are loaded, they are active, and there is status, running status. They are running, active, listening, mounted, exited, or whatever it is. Now we can use the same command, the systemctl command, to look at a specific service. For example, this service called crond, which we used in one of the previous classes, let's look at the status of this service. So systemctl status and then crond, the name of the service. It shows that this is the name of the service, this is the command scheduler, and this is the description that is stored in the unit configuration file for crond, right? And then this is the location of this crond.service file, which is under user lib systemd system directory. The service is enabled, which means when we reboot the system, this service will be automatically started up. And then it shows vendor preset enabled. So whoever the vendor is, Red Hat in this case, the default setting for this service is to enable it. And at the moment it is active, which means it is running. And it was started today at 9:39:13 Eastern Standard Time, 56 minutes ago. And this is the PID of this process. This is the PID of this process, and this is something called C group. And it shows the startup process. So the service was started at this time, and then any issues with the service, they are listed here. You can use the -L command to view more information. But as long as the service is active and running and it reports no issues, then you should be fine with that service. Now, systemctl is active. Let's say you just want to see whether the service is active or not. You can use the is-active subcommand with the systemctl command. Or you can say, I want to see whether this service is enabled. Enabled means it is set to auto start at the next system reboot. Enabled. Or you can simply run the systemctl status crond. We can also use, there's another subcommand called show. Systemctl show and the name of the service. It provides you all the parameters that are or that affect the service, the execution of this service. Restart, no, notify, and all of those parameters. There are hundreds of them that affect the execution of this server. 138 detailed parameters. You won't need to see them, in normal circumstances, but there's a if you're troubleshooting something and there's a problem with a service and you need to know what are all the parameters that the service is using while it's running, so you can use the show subcommand. I can use the same command systemctl to restart crond service. Restart means stop the service and then start it. Restart is equal to systemctl stop and systemctl start. The service has been restarted, and we can use the systemctl status command, and you should see a different PID this time because the PID was released when the service was stopped, and now a new PID is assigned to it. You can mark the service to not start automatically when the system is rebooted. And as you can see, I just executed this command, and as you can see on the screen, it simply creates a soft link using the ln command. It just says that do not start this service when the system enters multi-user mode. I can change it back to enable, and it recreated that link. So systemctl command has a number of subcommands options available. You can enable or disable a service. You can start, stop, restart a service. You can check the status of the service. You can see all the parameters that affect the service. There's a subcommand called reload, which means that do not release the PID of the process. Keep the PID, but with the reload command, you're forcing the service to reread its configuration file and apply any changes that have been made to the configuration file. Targets are logical collection of units. So basically, let's say I want to shut down my system. So we run this command called shutdown on our system. The shutdown command will stop all the services that are running on the system gracefully. It will unmount the file systems. It will stop the graphical environment. It will kick out any users who are still logged on to the system. It will um, it will it will stop the swap system. It will, stop any service or deactivate all the services that are running, and then it shuts down the system to a state where you can power it off. Or if you want to use the power off command, but the power off command will do exactly what the shutdown command does, but at the end it will also turn the power off to the system. Halt is also very similar to the shutdown command. Multi-user is another target, which means multi-user means that you are booting up your system. Multi-user means the system state where users can, or multiple users can log into the system. But multi-user target does not provide the graphical capabilities. Your graphics, your X window is still down. The graphical target means the graphical target means that the system is running in multi-user mode, plus the desktop environment is also running. So the difference between multi-user and graphics is just the difference between graphics running or not running. Production servers, we set systems to the multi-user mode in most cases because we don't want to see graphics. But there are production environments where you will see graphical target set. Reboot is similar to shutdown, but it will, instead of powering off the virtual machine or the physical system, it will restart it. Now, if you want to see if you want to, oops, systemctl -t target. If you want to see what targets are currently loaded on the system, you use the same command, systemctl. But with the -t option, -t stands for type. The type of the unit configuration that you want to see. The type is target. This is the name of the target unit. This is the load status of the target. This is the active, subcategory, and description. Basically the same information, except that the first column shows the target unit: basic target, crypt setup, Getty, graphical, remote, etc., etc. And then if you want to find out what your current default setting is for the target, it shows that graphical environment is our. We can change it to multi-user. For example, we run this command systemctl set default, and we want to change it to multi-user. Run this command, and basically what this command does, it remove the symbolic link that was pointing to, there's a file called default.target. So instead of modifying the configuration of a file, what systemd does, it simply creates a soft link or removes a soft link. So the actual information is still stored under the multi-user file, but it is pointing to the default.target file, so that when your system is rebooted, this is the file that will be referenced. Right? So now it is set to multi-user. At this point, if I reboot my system, I will not see the graphical desktop running on my system. Let's do that. Let me just quickly show you that. Well, I can issue the reboot command here. So I'm rebooting my system, and I want to boot up with the default kernel, and we should be able to see a text login on the console instead of the graphical. So when you see that bar on the bottom, you can press the F2 key on the keyboard to see a list of services that are being started. So we don't see the graphical environment now. This is the console. This is the login screen. Type the root command and enter the password, and you are in. There is no graphical environment here. There's no graphics here, right? Now, if I wanna, while I'm in the multi-user state, I can switch my target to graphical or to some other target. So we use the same command, systemctl isolate, which means that do not reboot the system, do not power off the system, switch my current target from whatever it is currently running to graphical. Specifying the extension is optional. So let's run this. Systemctl isolate graphical. I want to switch into graphical environment, and it is starting up the X window on it, right? Let me restart the session. Login as the root user, login as the root user password. I'm in, and systemctl get-default. The default is still multi-user because we haven't changed the default. The default boot target is still set to multi-user, which means without graphical. But we can always switch into the graphical environment. And if you want to systemctl isolate multi-user. If you want to switch back to multi-user, run this command. And where's my, there you go. There's no X windows running anymore. Okay. So we can use the systemctl command to determine the current default boot target. We can change the default boot target. We can switch between different targets. We can reboot the command, reboot the system, power off the system. If you want to use the reboot command, for example, you don't have to use a systemctl command to do it. However, you can still do it. Systemctl reboot will do exactly what the reboot command does. Okay. And that's basically it. So maybe you guys can try systemctl, some uses of this command, some usages of this command are listed here. You can try systemctl and work on the cron d service, because this is not a critical service. You can enable it, disable it, reboot your system and see what happens. Check the use the start service option, restart, stop, show and status on your computers is active, is enabled, and also try to change the default boot target, and then reboot your system and see what happens. Okay. Do you have any questions? Are you guys still there?
Yep.
Okay. Any questions? Well, this is a very big topic. Systemd is a very big topic. This is just the key or the key concepts. You can find more information in the book, or if you really want to, you know, study System D in detail, there's the website I think it's called um, I think the documentation is available. Let's find out here. Manual System D. As you can see, many options. This is the default option. That's why we don't specify it with the systemctl command. But if you want to use target, then you define -t and then name of the target. And concept. System D provides a dependency system between various entities. And if you want to learn more about what units are, you can use the man command. System D target, what targets are, services are, system D devices are, system D mount are. There are 12 different types of unit files. And you can find detailed information about each one of them in the section 5 of the manual pages. What is after and what is the before parameter? So all that information is in this file. And then this is the home page for System D. It is sitting on freedesktop.org website. The wiki is there for System D. Systemd.unit, and here is all the information in detail. Right. So there's a lot of documentation available on Systemd if you are interested. So let's take a break. It's 10:52 right now. Let's take a 20-minute break maybe. And or let's resume at 10 after 11 o'clock. So 11:10. And if you have any questions, you can send it to me via chat, or you can wait, when we restart. Okay? Okay, the next topic and the last topic for our today's class is system logging. So any activity that we perform on the system, they are logged. Specifically, any activities that are performed as a normal user but with root privileges. So all these activities are stored under one directory, and that the name of that directory is /var/log. And most other popular Linux distributions also store their log files under this directory. And if I run the ls command here, we'll see a number of files available there. So for example, let me run the ll command on Anaconda. It is a directory, and under that directory there are several log files. These log files are created when we install the operating system, and you can see the timestamp September 16, 1021. So September 16 is the cal 2017. September 16. September 16 is the day when we had our first class, right? So these log files were created when we installed this Linux system. And all these log files, they store different kind of information that was generated during the installation process. So for example, if I want to see um, anything that is related to the network configuration, this is the file, if CFG, if configuration. So pipe it to more, and here's the information, right? So these are the log files for the system installation created during the system installation time. Then there's a log file associated with all the yum activities that we have performed on the system. So if you look at this file, you'll see that we installed some packages on October 14th, and then we erased, reinstalled, and updated certain packages on the 14th, and November 25th, which is today, we updated and installed a package, right? So all yum activities are recorded in the yum.log file, and then there are X window log files. There is a spooler log file which stores printer related information. Then there is a secure log file which stores system security related information. For example, it let's pick up authentication information, user authentication, and anything that is related to authentication. And then there are, messages. This messages log file, which is the system default log file. So all messages goes into this log file. Now, unless the messages are marked for an alternative destination, this mail log file, which stores all the mail activities, email activities on the system, this last log file, and firewall D related. D message is the log file where all the current um, system messages are stored. This is the cron file, which is used by the cron D service, and the boot log file, which was just updated when I reboot my system at 10:45. So if you look at the boot.log file, this file stores all the services, a record of all the services that were attempted to be restarted. And if the service was started without any issues, you'll see an OK here. If the service failed, you'll see a failed message here. So all these messages, and these messages were generated when we boot our system, right? They're all recorded. Now, so the system logging is performed to keep track of all the messages that are generated. Now, the kernel of the operating system generates messages. The daemons or the services running in the background, they generate messages. The commands that we executed at the command line, um, they generate messages depending on which service we are running the commands for. The primary daemon, or the main daemon, or the only daemon that takes care of all the logging activities on the system, is called rsyslogd. And if we use the ps command and with the -eaf option and grab for rsyslogd, we should be able to see this daemon running right here. So this daemon is running. The PID of this daemon is 1014, and it was started by the process with PID 1, and we know that the process with PID 1 is the system D process. So system D started the rsyslogd service. The configuration file for the rsyslog configuration rsyslog service is located in the etc directory, and it is called rsyslog.conf. This is the name of the configuration file. There might be additional configuration for other services that are by default that are located in the etc rsyslog.d directory. There's only one at the moment. So the primary configuration file for the rsyslog service is located in the etc directory, and it is referred to as the rsyslog.conf. And this is the file where we can modify parameters and configuration to modify it according to our needs. In most cases, when we don't want to run any major application or any large application, the rsyslog configuration file is good enough for the for the system. Again, just like any other service, like the cron service and any other service, we can enable we can enable rsyslog D service, we can disable it, we can start it, we can stop it, we can check the status of it, or we can reload it without changing the PID of it. Enable and disable means that the service will or will not activate, will start at the next reboot. By default, it is enabled and it is started. So we can stop it, but there might, well, unless there is a reason to stop and restart this service, there is no need to do so. And the log files are located in the var log directory, boot.log, cron file, messages file, yum.log file. There are just a few of them. Now this is important. The rsyslog.conf file, which is located in the etc directory, stores all the rules for how this service should behave. rsyslog.conf. Let's take a look at this file. There are two sections. Actually, there are three sections in this file. The first section is the module section. And the module section, except for one module, which is this module, all other lines, actually two modules, all other lines are commented out, which means they are all disabled. So when this service is started, there are two modules that are loaded by the operating system. And those two modules are IMJournal and IMUXSOC. They support different services. And then in the next section, which is called the global directives, this section dictates the options and directives that affect the overall functioning of this service. So the working directory for this service is located under var/lib/rsyslog directory. Then this is a format on how to record messages. And this one here include configuration from the etc rsyslog.d directive for all the files with the .conf extension. Omit local logging is disabled for some services, and so on. And then the third section pertains to the rules. This is one rule. This is another rule. This is another rule for cron. And as you can see, we know that the log file for recording cron activities is /var/log, right? And cron is the name of that file. This is why it records it there. This means that record the cron service messages into the var log cron file. All emergency messages should be displayed on the screens of the users who are currently logged in. OMUSR stands for output messages, sorry, output module for user messages, which means that this is a kernel module and it is responsible for displaying any emergency messages on the screens of the users. There are additional services which are identified here and so on. So there are, let's, so these messages are logged to the messages file. These messages go in the secure file, mail log file, cron file, spooler and boot log file. Now let's take a look at the syntax of this config of the rules that are defined here. What does this mean? Asterisk.info and then there is a semicolon, mail.none, then there is a semicolon, then authorization privileges, and there is a semicolon. The semicolon is used to separate one service from the other. And in the asterisk.info, the value before the dot or before the period character is referred to as the facility. There are different facilities. Kernel is a facility, auth-priv is a facility, mail is a facility, cron is a facility. So these are different services. These are different services that are available or predefined on the system. UUCP is a service. Sorry, UUCP is a is a facility. News is a facility. And then after the period character, after the dot sign, info. This determines the severity of the facility. So there are multiple priorities: emergency, alert, critical, error, warning, notice, informational, debug, and none. These are different severity levels associated with the facilities. So for example, here asterisk.info, it means that all services, all facilities that are defined on the system, they're informational messages. No critical messages, nothing. We're specifically talking about general purpose informational messages. All of them will be logged to the var log messages file. Plus the mail system generated messages, none of the email generated messages should be logged to the var log messages file. We don't want, and that's why none means no messages for the email service. And here, no messages for the authorization service. No messages for cron. Why? Because we have separate log files defined for these three facilities. Auth privileges, auth-priv is right here. We want to record all the messages generated by auth privileges facility into the var log secure file. For email, we want email messages to be logged to this file. Cron here. All the emergency messages to appear on the user login screens, the user screens. UUCP is an very old service, Unix to Unix copy program that has been, I used this service back in 1991. It was available on Unix system at the time, and it is still available. Then there's a new service. Only the critical messages associated with these services will be logged to the spooler file. This is for any local messages. Local 7 goes to the boot file, which is var log. They are boot.log records all the messages that are related to the boot system, the booting of the system. So we have a selector field, and we have a priority field. This is the selector field. and this is the priority field. So selector determines the facility and its priority. And then there are different facilities and there are different priorities associated with them. If we really wanted to, let's say we don't want to see any emergency messages to appear on user screens, we can simply put a hash sign here at the beginning of the line to disable this service. Or we can change it to something else, depending on our requirement. The log file can be modified, this log configuration file can be modified, but only with the desired configuration changes, the changes that we want in our environment. Otherwise, in 99% of the cases, well, 90% of the cases, this log file configuration is good enough. If you want all your cron activities to go in the var log messages file here, then simply change mail.none to cron dot, simply change cron.none to cron.asterisk, and all your cron activities will be recorded in the var log messages file as well. So yes, there are different options available to it that you can use and modify this file. Other than cron and mail and some other services file, let's say there is a what other facilities do we have? Man rsyslog.conf. This is the configuration file and it shows us all the details. Global directives, the selector field, the syslog facility, the user facility, the UUCP, the cron facility, daemon, kernel, LPR is printer service, is printer facility, marking, news, security, etc., etc. So there are a number of predefined facilities, and then these are the priority levels. And the third item, which is not the third item, but this field here is called the action field, which determines the destination to send to record the messages. So for auth privileges, the messages will be redirected to the var log secure log file, which is the action field. Let's take a look at some of the log files. So cd into the var log subdirectory, and there are a number of files here. Let's take a look at the messages file. Now by default, we see multiple log files with different timestamp. This one is 2017 October 11th. This is October 28th. This is October 29th. This is November 25th. These log files are rotated, which means that when a certain number of days have elapsed, then a backup of that copy is created with a timestamp added to the name of it. Similarly, mail log file right here, different days. There is a configuration file which defines how often the log files should be rotated. So all this is customizable, and that configuration file is located in the etc sysconfig directory. But let's take a look at the messages file, more messages, and see what kind of messages are stored here and what is the syntax. November 25, 10:30:01. So the timestamp, and then the host name of the system where the message was generated, and then the name of the service that generated the message, and then a description of the log entry. So November 25, 10:30:01 on RHCSS01 host systemd log this activity starting session 8 of user root. And if we scroll down, let's go to the bottom. November 25, 11:10 RHCSA systemd started session 6 of user root. And then, different update UTMP about system run level. So this is the syntax of logging activities. The time is temp, the month and day, and then the time, host name of the system where this activity was generated, and the name of the service, followed by a description of the service. Most of the services are associated with systemd because systemd is responsible for the overall system and service management on our system. Let's take a look at the boot.log file. Boot.log. Well, this file is updated, or we can say refreshed when the system is rebooted. It's updated with new information each time the system is updated, and we can identify that by using the ll command on this file. And as you can see, 10:45 is the time when I rebooted my system. So this file was created at that time or refreshed at that time.